I'm Kimmy Frankenfield. My daughter is Ellie Jane. She's 3.5. Ellie is such a little character. She is just a bundle of energy, and she's so funny, and she's wicked smart. We live in Surf City, North Carolina, and we came up to have a pacemaker put in because Ellie has long QT syndrome.
Ellie has been cared for by our team since she was about 6 months old. It's a disease that predisposes her to heart rhythm abnormalities that can be dangerous and sometimes life-threatening. We've been monitoring her remotely, secondary to this little monitor that she had implanted when she was just a baby by our team. She's developed some pauses or some slowing in her heart rhythm where her heart stops for 3, 4, and 5 seconds at a time.
The pauses have been getting longer and more frequent. Because of the increase, they decided that it was time to put in the pacemaker.
My name is Hee-Cheol Cho. I'm an associate professor and the director of research at the Blaylock Tausig Thomas Pediatric and Congenital Heart Center. The topic of our research is the heart rhythm. The heart is an incredibly fascinating organ because each and every heartbeat starts as a tiny electricity. And the tiny electricity starts from a group of cells called pacemaker cells. We study the biology of these pacemaker cells, what goes wrong when our heart rate is not regular, and we engage bioengineering principles to come up with innovative therapies to restore the heart rhythm. The current state of the art for the patients whose heart rate is too slow is to get an implantable pacemaker device. One of the translational goals that we have is to develop biological pacemakers for patients whose heart rate is too slow. One of the ways that we do this is to bioengineer pacemaker cells from the patient's heart by injecting a natural human gene, and that would be the gene therapy. Alternatively, we use stem cell technologies to create patient-specific pacemaker cells in the dish by converting the patient's own cells. My research is directly aimed at creating bioengineered solutions for pediatric cardiac pacing so that our neediest patients can not only survive, but also thrive.
Talking to the amazing doctors and nursing and staff here, I feel so lucky to be able to come to Johns Hopkins to have the best of the best. But at the end of the day, they're still cutting my baby's sternum. And that's the part that every time I thought about it, about the surgery, that just gets me. And I'm really glad we are on the other side of that. I was so excited by even just the preliminary information, and then talking to Dr. Cho, who is phenomenal. Him explaining the gene therapy and explaining it in a very accessible way. It was incredible, and it was so exciting to think that I could, in the future, that she could actually receive these cells with a simple injection and not cut through her sternum in order to regulate her heartbeat. I think that's absolutely phenomenal.
The Heart Center is a really special place because it can provide comprehensive care for these patients. Ellie has required the care of a pediatric cardiologist, a heart rhythm nurse, our genetics team who initially made her diagnosis, a surgical team, and an ICU team.
That was a really core thought for me, to say, just focus on that gratitude that we have the option to come to Hopkins. There's just a lot of comfort I feel in knowing that we're working with such an incredible team.